This is a PayPal accounts page containing details about the account holder, the transaction, the account balance, and many other sensitive data. And this is only accessible by the account holder. This is the URL of the page. We know that website usually cache static files like CSS and JavaScript. So what the attacker did was he added a non-existing path with an extension .css, and that page got cached. The page with all the sensitive data. And anyone with this URL can access the page and all the details. So what kind of bug is this? Is it web cache deception or web cache poisoning? Let's find out. In the last video, we have seen how we can chain access control and cross-site scripting with request smuggling to increase the impact from a low to high or critical bug. Today, we will discuss what is web cache deception and what is web cache poisoning. I will explain to you in detail and also show live examples. We will also chain web cache deception and poisoning with request smuggling to increase your chances of getting a critical bug. This is the seventh video in our bug types and how to find bugs playlist. And this is the third video on our request smuggling series. Check out my other videos too. Let's start the video. First of all, web cache deception and web cache poisoning are two different things. So, what is web cache deception? In web cache deception, the attacker tricks the cache server into saving sensitive data. So, in the case of PayPal, when the attacker added a .css extension, the cache server thought it was a static file and stored it in the cache. And anyone with the URL got access to the private details. So, this is a web cache deception bug. Now, what is web cache poisoning? Think of it like this. What if the attacker is able to make the cache server store malicious data in the place of original files, like this alert? So, whenever a normal user tries to access the page, this malicious data is given as the response, and the normal user would get an alert. This is web cache poisoning. Now, let's see how we can make it practically happen. We will be chaining it with request smuggling. First, we will find what is the architecture. Is it CLTE or TCL based? We got the timeout. So it is CLTE. If you don't understand this, you haven't watched the previous request smuggling videos. I have explained all of this in detail. Now let's confirm it's CLTE. We get a 404. So this confirms the vulnerability. Now we will chain web cache deception with request smuggling. In this website, when we log in as a normal user, we get an API key. Now let's see the request in burp. Send it to repeater. When we send the request, we can see the API key in the response. So what if we are able to make this cache server cache this API key of other users? First I will remove the ID and send a request. Still we can see the API key. We will be caching this URL. Let's choose a static file tracking.js. You can see cache control in the response. So this is being cached. So the response of this request will be cached. What if we use request smuggling to add the account's URL on top of this request? Will it be cached? Let's find out. In our smuggled request, add the get request to slash my accounts and remove other unnecessary headers. Now, when we send this request, the smuggled get request to slash accounts will stay in the backend, and when the request for tracking.js arrives, the server will add this get slash my accounts onto the top of that request. The server will read the first get request and will give the response of slash my accounts, and the caching server will store that data. So whenever we request for tracking.js, we will get the sensitive data of other user. So let's see it in action. Here the cache control is 30, so it will cache after every 30 seconds. Let's send the request and wait till the age reaches 27. Now we will send our attack request. And then we will send the request to tracking.js. Now tracking.js will get the response of our smuggled get request. And if our timing is correct, after the 30th second, The sensitive data of a legit user will be saved onto the cache server. See, the API key is different, so it is the API key of some other user. This is how we use request smuggling to achieve web cache deception and make the cache server store sensitive data of other legit users. Now, anyone making a request to tracking.js will get this sensitive data of a legit user. This is how we show the impact of this bug. Now, is this a web cache deception bug? This is a bug reported to Shopify by an attacker and was awarded $3,800 bounty. Here, the attacker changed the forward slash to backward slash and sent a request to this JS file and then received a 404. But that response got cached, and whenever a legit user tried to access this JS file with a forward slash normal request, the user got a 404. What kind of bug is this? Is it web cache deception or web cache poisoning? Comment down below. After completing this video till the end, you will understand that. Now let's do web cache poisoning with request smuggling. We will also learn one more concept, open redirect. First of all, let's find and confirm if this is CLTE or TACL based. So here it is CLTE based. In our target website, there is an option to move on to the next post. So let's see how this request works. This is how the request looks. So a get request is made to slash post slash next and then the post ID. The response is a 302 status code, which means a redirect to this location. Now let's see if we can change this location to any other. If I try to change the host in the get request, I will get an error. Let's use request smuggling to manipulate this location. I will change the get request made to Zodiac to the get request of this request. Now we will send the request. Now go back to the get request made to the post ID and send the request. See, the location has changed. So there might be a chance of open redirect. What is open redirect? Take for example a login page. After we login, we are redirected to another home page. So what if we can change the location of this redirect to a location we control? That could be our server running malicious code. So we can run that code on the victim. Now let's see if open redirect is possible here. We'll add a host header to zodiac.com and send the request. And when we send the second normal request, our location is changed. So open redirect is possible. Now let's add the location of a server we control. This is the URL where our malicious code runs. Now let's add this URL to the redirect location. Go to the smuggled request and change the host to the server we control. And this is how we hunt for open redirect with request smuggling. We have chained open redirect with request smuggling. Now let's see how we can change open redirect and request smuggling to achieve web cache poisoning. Here there is a JS file with maximum age 30 seconds. As in the case of web cache deception, when it reaches the correct age, which means when it nears the 30th second, we will send our smuggled request and it will get added on top of this JS request, and hopefully our cache server will cache this response. Now let's see it in action. Send the smuggled request. Now send the request to tracking.js. And see, we are able to poison the cache and add the redirect location to the server we control. So whenever a legit user tries to access the web page, the user will be redirected to the malicious URL by this site. And our malicious code will run on the user's browser. This is how we exploit web cache poisoning using request smuggling. So we learned web cache deception, open redirect, web cache poisoning, and chaining this all with request smuggling. This is my channel. I make contents in bug bounty, reverse engineering, API, and APK hacking. This is my Instagram, Twitter, LinkedIn, and Twitch accounts. This is my GitHub page containing links to my write ups and blogs on CTF, reverse engineering, bug bounty, and many more. This is my blog. Follow me if you like my content. I also have another channel for creating bug bounty content in Malayalam. You can see it in my home section.